The first one is called the remainder theorem. And basically what it means is that the remainder, when a polynomial is divided by some linear factor, x minus k, the remainder is going to be whatever that original polynomial would be if it were evaluated for the 0 at that factor. Okay, and so what that means is if you were asked to find the remainder when you divide this expression f of x by x plus 4, you could use synthetic division, right? I'm going to go through that, and this is where next year it's likely you would be asked to demonstrate this. But if you took this polynomial and divided by x plus 4 using synthetic division, you would write your coefficients 5. There is no power of 3, so I need to mark that with a 0. Negative 6, 7, and 6. And because we're dividing by this factor of x plus 4, what 0 is associated with this factor? Negative 4. And so what we can do with our synthetic division, we drop the 5 down, multiply, add down, multiply, add down, multiply. 4 times negative, or 74 is a negative 296. Add down and multiply. Again, when you take negative 4 times negative 289, you get 1156. Add straight down, you get 1162. So again, doing synthetic division for this particular problem still would require your calculator. And so what you see is this is your remainder. An easier way than or if not easier, but a quicker way than to go through the synthetic division of this might be to just take your original function, evaluate for that corresponding 0, and that's going to be equal to your remainder. And so let's confirm that here. So if we took our function right here, I'm going to write it 5x to the 4th minus 6x squared plus 7x plus 6, and I'm going to evaluate it using the with key at x equals, and again, the corresponding 0 to that factor, bless you, is negative 4. So when I evaluate that function at negative 4, I get 1162, and you see that that was exactly what the remainder is when you use synthetic division. So the remainder theorem is just another way that if you're being asked just to find what the remainder is, you can use synthetic division, or you can evaluate the function at that given 0 that corresponds to the factor you're dividing by.